Hello everyone. Today I am going to deliver another lecture on design of tension member. This lecture only focus on block shear failure. I have I have given another lecture which is tension member design, which is yield failure and fracture failure. So I will not focus these two failure. Rather today I will focus on the block failure. Okay, let's start. Uh, uh, Before starting, I want to say what is the block shear failure. If you see this diagram, okay, I'm starting here. So there is a tension member design. I've already mentioned the tension member. So it could be beam, it could be sag rod, and so many things. So I have been giving the yield failure and fracture failure. Now today I'll discuss on the block shear. So block shear is the two type. You can see the tension rupture. Here's we can see one is tension in rupture, another is shear. So shear is divided on another two, which is shear yielding and shear rupture. So if we see in one line, so you can see the block shear will be a tension of rupture plus smaller. So we will take the smaller portion of these two, which is shear yielding or shear rupture. So if we draw the if we write it in a what else in a formula, then we can see by LRFD Tn equal to 0.75 Fu into ANT, which is called tension rupture, and then smaller portion of shear yielding, which is 0.60 FYAB or 0.60 FUANB. If we solve this problem with ASD, then it will be 150, which is 1 by half, and FU in ANT, which is called tension rupture, and then smaller portion will be this type, which is one is the shear yielding we have been seen, and another one is the shear rupture. This is shear rupture. Okay, so let's see how the block shear failure. You can see this is the plate and angle. We have been seeing the two type of mode. What is mode? Mode is the which path is it is shear the failure. So we have been seeing the rupture is occurred or tearing. We can see the tearing of the shaded portion are coming out from the bolt. On the other hand, we have been seeing another mode, which is we have been seeing the this type, the tearing are tearing the what I will say tearing the plate from this path, and the shearing failure is occurred this line. So if you see the clearly in picture, then you can understand what is happening in shaded zone. And this is the another example of block shear fail. This is we can assume the three type of three type of failure can occur. So first we can assume the mode one, which is it is occurred this type of failure, and the shaded portion is come out from here, and two bolt is here. On the other hand, we can see the left portion also tearing with this block, and the right portion will be remain stable with the structure. And third one, we can see here the all the portion will be come out with when we load applying on the load. So if you want to visualize in graphically, you can see here, you can see clearly. If I zoom it, then you can you can understand that you can see the block shear path 1. We can see the all the block is coming out, and we can see the path 2, the only the bottom portion is come out with this layer, and another path we can see the top portion is come out when the tearing when the load is applied. So we can see here another picture which is block shear failure mode. All the plate is come out when we apply the load, so it is called block shearing. So this is the we can see this is the actual scenario in practical field how the block shear is occurred. So you can see the actual in practical field the all the bolted region are come out when the load is applied or when the applied is load on the structure. We can see another picture also at block shear failure in the practical region. Uh, okay, so let's move on our main lecture. Okay, so I want to like to I want to like to do the more example. That's why I'm starting the example one. So here is an example. The investigate the tension capacity of the plate is given plate 8 into 5 by 8 in attach to a gasset plate with a 4 bolt. 4 bolt is given 1 2 3 4 in figure shown below. The material is a 36 in Fy equal to 36 and Fe equal to 450. Bolt are 3 by 4 inch diameter with stamped hole. Consider all the limit state, yielding, fracture and block. So we are considering all things. Okay, use the LRFD ASD method. Okay. So at first I'm solving this as yielding failure. So I'm using AG 8. We have been used 8 as the given is depth 8, and the thickness is given 5 by 8 and found AG equal to 5 inch and AN equal to WN which is given 5 inch, 1.5 and 1.5. So it will be 8 inch. So this is the 8 inch total 8 minus 2, which we are considering the two holes, and dia bolt we have been three is given 3 by 8 is given in question. We are already shown here. And 1 by 8 is a constant, what I will say, the constant with the bolt dia, as we previously mentioned. If we will consider the whole, then it will be whole plus 1 divided by 16. But if we consider the bolt dia, then we will consider bolt dia plus 1 by 8. Okay, and now s square by 4g, which is staggered. We are considering the staggered, and plate thickness which is 5 by 8 is given. So staggered we have been calculating this portion. So as equal to this horizontal, which is 2.5, 4 into 5, 5 equal to vertical distance and square and 5 by 8, and found as equal to 4. And LRFD, we are using LRFD method and found 162, and using ASD method and found 182. For fracture, we are considering the fracture. We have used 0.7 and found 178 and found 118. So here is the formula on ASD using ASD and LRFD and ASD using yield, fracture and block shear. Okay, so now our focusing is the block shear. So there is a two mode 1 and mode 2. So in this topic I am also clarify yield and fracture failure. So I am uncutting here. So now I am covering the block shear failure. So block shear, we can see consider two type of failure will be occurred. In we have been seeing the shaded portion. This plate will be come out, but that portion will be remain same. On the other hand, we have seen the mode 2. This portion will be also come out with when the tearing will be occurred. So ABG, which is the length of along the shear. Okay, so what is the ABG, which is along the shear into plate thickness. Okay, so you've been seeing the along the shear is occurred in this portion. So that will be 1.5 into 2.5. So this is the length, and 5 by 2 is a plate thickness, and 2. Why we will multiply 2? Because the 2 it is occurred the shear is two part 1 and part 2. That's why multiply 2. Okay, A and B. Here is the effective shear length into PT. Shear length. What is the effective shear length? What is without hole? Okay, so the shear the length will be along the shear. So we have been seen 1.5 into 2.5, 1.5 into 2.5 minus n is 1 plus 1.5. Okay, uh, we have been seen 1 into 1.5 into um, 1 plus 1.5. So we are considering why 1 plus 1.5, why not 2? Just because of if we see the failure mode, we can see the this bolt is taken consider is fully. On the other hand, another bolt is consider is only half, not fully. That's why we are taking 1 plus 1.5, which is 1.5. And the bolt die is taken. This picture we can understand why we are considering 1.5, 1 plus 1.5. So that will be 1.5. Okay, and dia we have been shown here on 3 by 2 and plus 1 by 8, and there is no shear lock, s square staggered. That's why that will be s square plus 4g and 5 by 8, and it will be occurred also to along the two path. That's why we are multiplying 2. And now effective tension length we have been seen here. Tension length is 5. We are seeing here the tension length is 5, so there is no doubt at all. Okay, so tension member is length is 5, and we have been seeing the half. Why we are taking half? This is the graph. We are taking the half hole and half hole. So if we consider this portion there, then it will be half and it will be half. So that's why we are taking half of upper and half of the bottom. What I will say, the bolt. Okay, and 3 by 4 is also bolt die, and 1 by 8 is a constant, and there is no staggered, and the plate thickness is given remain same. So we have been found 2.8. And LRFD, we have used the LRFD method 0.75 FU and T and FY, and found 193, or we can use this formula and found 200. And by ASD we can use 0.50 FU this formula and found 29 kilonewton, and Tn equal to we have been found 0.33. So in the same way we have been used the we are seeing the block 2, what happening in mode 2. Sorry, not will be block 2. So mode 2 we have been seeing this portion will also come out when the load will be applied, when the failure is occurred. Okay, let's see. We know the ABG we have been already found. It is the length along the shear. So you have been seen here the 1.5 into 2.5 and 5 by 8 into 2 as a plate thickness is 5 by 8, and 2 is multiplying it is occurred in the 2 along the shear between bottom and top. That's why we are multiplying 2. And A and B effective shear length, we know the shear length 1.5 into 2 and 1.5. Why 1.5? We know the this bolt is taken fully and another bolt is taken half. That's why half into 1 into half, which is 1.5. So that's why we are taking the 1.5. And 3 by 4 in the bolt die, and 1 by 8 is a constant, and there is no staggered. Here so y s square by 4 is equal to 0, and 5 by 8 is a plate thickness, and 2. Why you are taking 2? Because we are considering the two type of shear we have been seen at the top and bottom. Okay, and to have been known the effective shear length and area and depth and the thickness. So we have been known the tension length which is given 1.5. Here is a 1.5 the tension. So remember that in the previous in mode 1 we have been taking the shear length is here 5. Now the mode 2 is the shear tension length is 1.5, this portion. So this is the tension length, and 1.5 is only one bolt is considered as the tension we have been calculating. And 3 by 4 is as usually bolt die, and 1 by 8 is constant, and there is no stagger. That's why 0, and 5 by 8 equal to plate thickness and 2. Why will taken 2? Because we are taking considering the tension in when it's calculating top and when another is calculating in bottom. So and in this way we found 1.33, and using LRFD formula and found 139, and or we have been using another formula which is 146. And in the same way we are calculating the ASD method and found 93 kilonewton and found 97 kilonewton. So if we know the LRFD method, Tn equal to 393 is greater than 139. So 393 and found 139. Okay, so where is 139? Okay, let's see. I have been mistaking maybe. And Tiga, okay. I'm finding here. In the LRFD method we have been found 139 here, and another method we have been found 193. So we are taking the less value, which is 139. In the same way we are taking, if we consider the ASD we will taking here, but we are emphasizing encouraged to do this math in LRFD method. So in the same way we are taking the ASD method. So we have been thinking 139, here is the left side, and another was found 93. So 93 is used. So if we summarize this result shortly, then we can found yield. We have been found by LRFD method the yielding result in 162. So if we go to the here, and fracture, in this way fracture we have been found 178, and in block shear we have been found 139. So structure will be failed after 139. So we have been seeing the three type of failure. We have been seeing yielding, fracture, and block. So when we consider the block shear 139 as a smaller load, so block shear will be failure before the fracture and yielding. So so we can calculate another is you following the ASD method. In the same way we can see the yielding is found 139, and fracture will be occurred when the applied load is 118, and block shear will be occurred when the load is applied 193. So we are considering structure will be failed after 193 load in a block shear. So this was the main math example. So I will see another example. We can see here the another example. Investigate the tension member capacity plate is given 5/8, 8 into 5/8, and attached to the gasket plate with the 6 bolt, and figure is shown bigger. Here is the figure, and consider the block shear mode only. So I will share only block shear. So I will not calculate the yielding and fracture mode. Okay, so let's see. And assume the uniform tension stress and the material is 58, and the bolt are 3/4 inches and dia with the standard hole, and use the LRFD and ASD both method. Okay, let's see. So at first we are considering the two mode. Mode 1, what is mode 1? Mode 1 we are considering the and the inner portion will not come out and outer portion will be come out. These two. And on the other hand we have been seeing the block 2 is the inner portion will be tearing with here. So at first I am going to finish the mode 1. I will calculate ABG, which is the shear, the length of shear, which is length we can see here. Shear length is along the shear and plate thickness. So what is the shear length? This is the shear length we have been seeing is given here, 2 into 2 into 2. So this is the shear length, and 5/8 is the plate thickness. And why we will multiply 2? Because this portion will be on the bottom, and we can see the also top. That's why we will multiply the 2. ABG, which is the shear length, we have been seen here, 2 into 2 into 2, and 2.5. Why 2.5? Because we are considering this. If we consider, we can see this whole dia will become, and this half dia will become. So we can see in the larger scale the figure will be like this. This is full, and this is half. That's why 2 1 plus 1 plus half, so this will be 2.5, and this is the 2.5. And bolt dia is given 3/4, and this is the constant 1/8, and there is no staggered in considered, that's why it will be 0. And plate thickness 5/8, and we are multiplying 4 because the 2 zone is we have considered. In the same way, we are considering ANT. The tension length is along the tension. This is the along the tension to 2 into 1. Oh, sorry, this is not tension. This is the shear. So tension zone will be this portion. So this is the 5. So length is 5 and 1. Why are you considering 1? Because in this bolt half into half, this will be, if we draw this and this. So this half and this half will be 1. That's why we are using 1, and 3/8 is bolt die, and 1 plus 8 into constant, and there is no staggered, and 5/8 is the plate thickness, and found ANT is here. Now we are using this formula and found 162, and another is found 166. So the small is 162. So now we'll see the another mode is mode 2. This is the mode 2. Why we will call mode 2? Because we are considering the plate could be failed in this phenomena. Okay, so ABG and ANT will remain same from mode 1 and mode 2. So that's why must be same there. That's why we are not calculating again. So change will be ANT, which is the length of what is the ANT? ANT is the length along the tension, and n into bolt dia into 1 plus n into s square into pt. So we have been seeing the length is here is 1.5. Sorry, this it will be not tension. So tension will be occurred in this portion. So we can see 1.5. So here is a 1.5, and 5.5 is a only this bolt will occur in tension. When the tension is occurred, the bolt will be failure in half, and the bolt dia 3/4 into 1 plus 1.8 is a constant into 0, and 5/8 is a plate thickness, and 2 I will calculating 2 multiply 2 because we are considering an upper portion, and when we are considering the bottom portion, then we have to consider 2. And in this case we have been found 162, and we are, if we use this formula, and found 162. So after this founding, so we are using LRFD method and found 233.7, and if you use the ASD method and found 155.8, and for mode 2 we have been found LRFD is 179.3, and ASD found 119.6 kilonewton. So the final result, if we concluded that for mode 1 if we found 233 kilonewton, for mode 2 we have been found 179 kilonewton, as we have been taking the small portion. So now we will consider the small, which is found 179. So the structure will be failed after 179.3 kilonewton load, which if we applied on the structure as per LRFD method. And if we consider the by ASD method, we have been found mode 1 is 155.8, and mode 2 we have been found 1998. Here is a 1558 and 198. When we taken the LRFD method, for mode 1 we have been taken 2.233, here is a 233, and another is mode 2 is 179, here is a 179, and taking the small value. And in the same way we are taking the ASD method and taking 155 and 199. So we can see the 199, if we the structure will be filled after loading 199. Okay, so let's see another example. This is the last example. So let's see. Investigate the tension capacity of the angle, which is L4 into 4 into 4, attached with a 3/8 inches thickness gasket plate with 3 bolts as figure given shown. Consider the uniform tension stress. The material is a 36 steel, and bolt are 7/8 inches square dia with the standard holes, and given X bar is given. If X bar is does not given, then I calculate and how we'll get the x bar. So it is comes from our what I will say the AISC manual. This is the AISC manual, American Institute of Steel Construction. Okay, so but it is given here, and consider all the limit state, yielding, fracture and block. So we will calculating all. So I'm reducing here. So okay, and let's see where. For we are considering section A and BB, so section A and B and found and W and 4. 4 is this is the weight of 4, 2.5 into 1.5, which is 4, and n number of bolt is 1. We have been seeing here 1, and bolt I have been this is the given in question, which is 7 by 8, and 1 by 8 is a constant, and s square by 4g as if we consider this staggered, there is no staggered, and pt is it plate thickness in 1 by 8, it is given 1 by 4, and found 0.74. okay, and then x bar is 0.58 is given, L equal to 3 into 3 into which is 6 inches. Now we are seeing the u1, which is 1 minus x bar into L. X bar is given and which is found 0.90. We are using this formula and found 0.60. As we are using 4 plus 4 plus 1 by 4 as we have been seeing here, and found 1.90. As so fu equal to 36 and fy equal to 37 and fu equal to 50. Now we will using for yielding. Now we are considering the yielding. So yielding failure. So at first we are considering the yielding failure by AFDUE. If you use the LRFD method, then we will found 63. If you use ASD method, found 42. And second one, if you use the fracture failure consider, then it will be 29, and the for ASD will be 19.8. Now this is the vital important, which is the block shear failure. We have to consider the mode. What is mode? Mode is nothing but which pathway will be failed. This is the called of mode. So at first we have been consider the bottom portion will be not tearing with the upper plate. So upper plate will be tearing, and the second portion we have been seeing here, the upper plate will be remain same with the structure, and the lower plate will be tearing. So these are the mode 2 and this is the mode 1. So let's start the mode 1. So as we know, mode 1, this is the mode 1. BG, which is the length, length along the shear plus plate thickness. So this is the shear we have been occurred, and which is the length 1.53 into 3, and plate thickness is we have been found 1 by 4, and we are multiplying 1 because there is no another bolt. If you another bolt, then the failure is occurred in another phenomena. That's why we are multiplying 1. okay, so effective shear length, it will be shear length of along the shear. If we see here, here the same as 1.5 into 3 into 3. So 1.5 into 3 into 3, 2.5. So why we will call 2.5? As we've seen the three bolts. So this bolt, and this is the half bolt. As the we have considering the tearing will be here, and so the phenomena will be like this: one bolt is fully, another bolt is fully, and last one will be half. That's why we are considering 2.5, and bolt die is given in question. So there is no issue. 7 by 8 and 1 by 8 is the constant, and there is no stagger to will be used. That's why we will be using 4 as 0. And the plate thickness is given in question 1 by 4 and 1. Why we will be using 1? Because we have been seeing the only 3 bolt is 1 row. If we we have found another 2 row, then we have to multiply the 2. Okay, let's see the ANT. So effective tension length. We have been seeing the tension. The length will be tension along the tension. So what is the tension? This is the tension zone 1.5. So on the other hand, if we consider the block mode 2, then the tension zone will be this 2.5, not the bottom portion. Okay, and the tension 1.5, and 1.5 is bolt, half of the bolt, and the bolt die is given, bolt die is given also 7 by 8 to 1 by 8, and there is no staggered, and bolt thickness is 1 by 8. And if we use the LRFD method and found 41.33 and 43.5. If we use the ASD method and found 27.5 and 29. Now we'll see the second mode. We are considering the second mode. The bottom portion will be tearing when they apply the load. So as we know, the ABG and ANG will be remain same as the first mode and second mode. So that's why we are not calculating again. Now we will calculating the A and T. We have been seeing the effective tension length. So we have been seeing the effective tension length will be here 2.5. Here is the 2.5, and the 1.5 is a half of the bolt. So bolt only we have been seeing the one row is occurred, and the bolt is given 7 by 8 and the remains same, and the 1 by 8 is the constant, and the staggered is 0, so there is no staggered is 0, and net thickness equal to is given is 1 by 8. We are seeing here. And by LRFD method, if you use the LRFD method, and we have been found 0.70 FU unit A and T plus 0.60 0.60 FI into AIB. Okay, I'm sorry for interrupt. And found 52.2, and then if we use the another this formula and found 54.4, and the same way if we use the LSD method, then it will be counted 34.8 and found 36.2. So if we consider the smaller portion, which is 38.8 kilonewton by LRFT, ASD, in the so if we finalize the result, then the result will be like this. By LRFD method, if we have been found for yielding, which is 63. So I will get we are going to the first portion. So this is the first portion, and we are considering the yielding, which is 63. And then fracture, we have been found 23. If we use the fracture for 29, sorry, it will be 29 and 29. And floor block shear, we have been found 41.33. So I will get this is the block shear we have been seen. This is the LRFT. So we have been found 2 for 41 and 43. So we have been seeing the we are taking the 41. So in this three result, we are taking the less load, which is we have been found 29. So therefore the tension member will be failure after 29 load. So it will be failed in fracture mode. In as per if we consider the LRFT. In the same way, if we summarize the ASD method, the yielding load is 42. We have been go to the here the 42 for yielding, and for fracture we have been found 19.4, which is 19.4, and for block shear we have been seen the block shear. Here is a block shear. We are taking 34.4. So this is the 27. Okay, this is the 27. Is a very as the lowest value, 27, and of them of the three results we are taking the most lower value. So therefore the structure tension member will be failed after 29.1 keep load. So it will the fracture mode will be fracture. So these are the lecture has ended. So this is not a block shear, so we can see the yield, the both three yield failure, fracture failure, and block shear failure. So If you have any question on these issues, then let me know. I will try to convince you, try to give your answer. Thank you, everyone. Thank you. So remember that the block share is very important, and it's happening, and you have to assume which mode is operating, such as the mode 1 and mode 2. So we can convert it another mode 3 or mode 5 and mode 6. So I'm not explaining mode 3 rather than mode 2, which is mode 3, 4, 5, 6, as it is takes more and more time. That's why I'm summarizing. I'm trying to the reducing time in this lecture. Thank you, everyone.